A very good evening to all of you. Myself, Engineer Sunny Agarwal, and I'm going to teach transportation engineering. So today I'm going to teach about sight distance elements. So actually, the geometrical design of highway is done in such a way that at every point on highway, the length of view available should be sufficient such that vehicles could be stopped in that particular distance. So mainly there are 5 types of sight distance elements which I am going to discuss here right now. Well, the first one is stopping sight distance. Stopping sight distance. So it is absolute minimum sight distance. This is the absolute minimum sight distance. Now I am coming towards intermediate sight distance. Intermediate sight distance. And it is exactly 2 times of stopping sight distance. This is just 2 times of stopping sight distance. I will just go on details about it, but I am just giving a view of all the sight distance elements. And the third one is overtaking sight distance. This is mainly used for safe overtaking operation. And the fourth one is headlight sight distance. Headlight sight distance. So this is headlight sight distance. So this is distance available to driver under headlight illumination. And this is very much used in case of valley curve. So I will discuss this later on about valley curve and summit curve. This is valley curve and this is summit curve. Summit curve. While the last one is sight distance at intersection. So let me rub it first. Sight distance at intersection. So for this particular sight distance, I would like to show a schematic representation. Like this is a road system, and vehicles are going in generally this particular direction. Suppose a vehicle named A and there is another vehicle B. They both are trying to cross against this. So for that there is a particular distance which is required, which is side distance at intersection. Okay? So I will discuss about it in detail. So now I am just going to give a brief idea about stopping side distance. Stopping side distance, what it is and why it is required. Suppose in a highway, single lane highway or multi-lane, suppose a vehicle is going and is interested to overtake other vehicle. Then what amount of distance is required? For that, the stopping side distance concept is considered. So here we will consider a vehicle. This is a vehicle schematic picture moving with velocity v. This is moving with velocity v in this particular direction, and there is a I am just trying to give you about idea about stopping side distance. Okay, so this is obstruction. Suppose a vehicle is moving in this particular direction of road with a velocity v, and he feels that due to certain obstruction or any issues, he is interested to stop. So how much proper length is required so that vehicle will stop without of any accident or any mishappening? So this we can deal here. So suppose this vehicle is moving with this velocity v, and it requires a time t, which is known as reaction time. Reaction time. This is the time in which the driver feels that he needs to apply brake so that he will stop and prevent from collision with this obstruction. So as we know that velocity into time is distance. So this distance is known as lag distance. This is lag distance. Lag distance. Lag distance. Lag distance. Velocity of the moving vehicle into the reaction time of the driver. This is lag distance. And there is also a condition: after the application of brakes, vehicle will not stop suddenly. It will go and travel a certain distance. That is, we will say it as braking distance. After the application of brakes, vehicle will move this particular distance before it will stop. So this distance is known as braking distance. So this distance we can easily find it. So what we have to do for this? Now, just like this, that suppose this vehicle is resting here and there is a normal component of its weight, which is mg, and due to friction, this is the lateral and longitudinal friction concept we will discuss here, that due to this friction the component is acting mu into n is mg. So now we will equate it like kinetic energy equal to half mv square, as we are knowing it very well, and we will equate with this component of normal reaction, mu n, and mu n is mu mg, and as you know that this is coefficient of lateral friction. So now we may cancel out m from both sides, and thus we will. Okay, there is also a component. This is mu mg normal reaction force into displacement. This much you have to equate with kinetic energy. Thus, you will get the value of L. We have to find L, breaking distance. This we require. So, L is equal to V square by 2G. So, this is L is breaking distance, and this D is lag distance, and both when we add it, it will give us stopping side distance. So, in particular, stopping side distance is Vt plus V square by 2 mu G. This is the derivation of stopping side distance, and later on we will discuss some numericals. And there is certain so as per IRC, Indian Road Congress, IRC recommendations, as per Indian Road Congress recommendations, the braking distance, when we find, we require reaction time, and that reaction time of a driver is considered as 2.5 seconds. Generally, the reaction time is considered as 2.5 seconds as per IRC recommendations. And okay, now we will do a derivation. Suppose vehicle is moving in an inclined plane. Okay, suppose it is inclined at an angle theta. This is an acute angle which is less than 90 degree, and our vehicle is resting here. Okay, suppose it is moving, no issue about it. So this is the normal component, and as we know, this is mu n due to frictional forces, keeping into account. And now we will try to resolve it. After resolution, so this is normal force mg, and this is mg cos theta and mg sin theta, mg sin theta. So here we have to calculate braking distance. We have to keep in mind about the braking distance. So braking distance L, here L we can calculate by knowing it, by adding these two components, mu mg cos theta plus mg sin theta. This component we have to equate with kinetic energy, which is half mv square. Now we have to equate it. So what we can do, here m and m, we can cancel it very easily, and thus L can be equated as V square by 2 mu g cos theta plus g sin theta Okay, this we can get very easily from it. And okay, we can also do one thing, that we can take cos theta out of it. So what will be remain here? Mu plus tan theta. Okay, no issue. Okay, so this is when it is going in up gradient. Okay, now suppose when this is only the case when vehicle is moving in upside, while in the reverse condition, like here, when suppose vehicle is moving in this particular direction, then nothing will change, only this plus sign will be replaced by a negative sign, and this will be same. Okay, so there is some important points which is very much required to be noted in this stopping side distance. So I would like to share with you all. So the first important point is that on a single lane road with two-way traffic, that traffic is in both direction, then stopping side distance is generally considered as two times of stopping side distance. Stopping distance is exactly two times what is coming from this formula, the previous formula which I have discussed earlier, and that we will consider exactly two times for safety purpose. And if the highway is undivided, it is not divided, that means divider is not provided, and it is a two-way traffic, that means vehicles are coming from both directions, then correction of gradient cannot be applied. That means gradient correction that we will discuss here later on will not be applied. And however, for divided highway, that means the vehicles are coming on both directions, but their divider is provided. In that, gradient correction should be accounted. And the last important point is, that means we have seen gradient correction like this. If vehicle has to go upward or downward, then gradient correction will be occurred. And okay, so mainly stopping side distance cannot be provided at a particular stretch. Suppose that due to certain limitations we cannot provide stopping side distance, then we can consider some sign boards, so that the driver will let him know that there is a signboard given to reduce its speed or to have a clear vision. And the other one is overtaking side distance. So why we exactly use overtaking side distance? So actually, for instance, a driver is moving with this particular speed, and he is interested to move with a higher speed. Then in due course of time, he will see that there are various other vehicles which are moving. So he has to overtake them, so that he can maintain his vehicle at a very high speed. Okay. So for that particular task, overtaking side distance is required. So we will see how we can do it. Suppose a vehicle named A. This is a vehicle named A. Okay. This is moving with a velocity Vb. And there is another vehicle. This is another vehicle. These are moving in a same particular road, moving with velocity it is also moving in a same speed. Suppose we can say that these two are moving in a same speed, but driver of vehicle A decided to overtake this vehicle. So what he has to do? He has to follow a path like this. He will come, and then again this type of path he has to take. First what? He will decide that I have to overtake it. So he will come here and then it will change its path and again it will follow the same lane. This is the trajectory. So how it will be done? So suppose first driver A will decide that I have to overtake this vehicle. So it will take some reaction time so that he will decide to overtake. That time is the reaction time. So we will consider this particular distance between A and B. Sorry. And we will name it as A1 and A2. So we will name this distance as D1. We are naming this distance as D1. So D1 is the distance traveled by vehicle A1, and this is the same vehicle. I am just naming it. Okay, let it be A. Okay, no issue. So from here to here, it will come and travel a distance of D1, and this distance will be traveled. We can know by multiplying VV into T, where T is the reaction time, and this vehicle is moving in with velocity VV. Okay, and suppose after overtaking, this vehicle overtakes B by following this specific manner and arrives here. And again, it will maintain a specific distance. The distance between two vehicles will be maintained. And we will generally consider this distance as S. S. Okay? Wait. And this is moving with velocity Vb. So a minimum distance will be always be there between two vehicles. So actually this vehicle is also moving, so it will also travel some distance in due course of time. So that distance is Vb into capital T. This is some specific time which is required to travel a specific distance, that we will see. And after this, suppose that this is another vehicle coming from opposite direction. So first A will decide that I have to compete B, and he has to also take into account that other vehicle will also come from opposite side. So what it will do? It will follow a path like this. It will go here, and again he has to come in its own path, so that it will prevent its collision from C coming from opposite direction. Now, okay. So mainly this distance we can say it as D3. Distance between A and C will be taken as D3, and this distance we are naming it as D2. We are taking it as D2. So what is D2? D2 is 2 times of S and this much distance. So here we can say that D2 is Vv into T plus 2S. Here this capital T is not a reaction time. This is not the reaction time. We will consider about it. And so now, so what is overtaking side distance? It is the sum of D1, D2 and D3. Overtaking side distance is sum of D1 plus D2 plus D3. Now we will see. Okay, thank you so much. Okay sir, कोई इशू नहीं है.